Okay, so we're going to be doing the exercises, probability exercises, working with obviously the different laws, working with the classic probability, the empiric probability, the multiplicative probability, and the other laws, the conditional probability laws. And we're going to be working on 9 different exercises so that we can review those. Okay. Exercise 1 is the first card drawn from a deck of cards of 52 cards, because a deck of cards has 52, is a king. Okay, so that's, you've done it. What is the probability if you return to the deck of cards, that first card that you drew? What is the probability of getting a king if you draw it again? And what is the probability of you getting a second king if you draw again without returning that card? So if you remember, these do not depend on one another. They're not, these are the classical probability where we are going to be drawing this, okay? So question 1, the probability of A, of you getting a king, the first time, taking that we've already drawn one and returned the card, is we have 4 kings in the whole deck, and the whole deck is 52 cards. That means this is the classical probability. That's the number of favorable outcomes divided by the number of possible outcomes. And that will also be the case in the very second one also, which, let's say this is the probability of B. Probability of B is going to be, how many chances do I have? What is the favorable outcomes? Well, the favorable outcomes of this is going to be 3 kings, because we already have one in the probability of A. So the 3 kings, and how many cards do I have of all the possible outcomes? Well, I have 51 cards now, because I didn't return the first one. So it is the 0.58, okay? What is the probability of getting 2 kings in the first 2 draws? Keep in mind that you don't replace the first one. So if you remember the laws in this particular case, this is the multiplicative probability law. And this is for independent events. I mean, they're not dependent one on the other, and this is fairly simple. So this is going to be that you're going to get an or. That what is the probability of getting 2 kings on this? Okay, so basically this is going to be the intersect of A, and I really don't, in my keyboard I don't have it, and I don't want to waste so much time in getting it, so let's put, I'm going to get I'm going to put inter of intersect and B, okay, and this would be the probability of A times the probability of B, and that 0.45 is going to be the probability of getting 2 kings in the first 2 draws. Okay, so there it is, and there is my answer. Those are the ones we got. Here we are applying the multiplicative law because there's 2 different possibilities. Okay. Now, consider you select a random student in a given university. Probability of A, or A, the event A, is going to denote the event of a student having a Visa card. And the probability of B is going to be that that student has a MasterCard. So we're going to assume that the probability of A, which is the Visa card, is going to be 0.5. The probability of having a MasterCard is going to be a 0.4. And the probability of the student having a MasterCard and a Visa, the intersect, is going to be 0.25. So it's going to be, first, determine the probability of selecting a student, an individual with at least one of the 2 types of credit cards. Okay, so it's going to be an or. Then it says, what is the probability of selecting an individual that doesn't have a credit card? One who's neither A nor B. Okay. So let's go ahead and do that one first. So it's question 2. So we have the probability of A, the probability of B, and it shouldn't be there. Probability of B. Okay, the probability of A, if I'm not mistaken, was 0.5. The probability of B is going to be 0.4. And the probability of both. I'm going to put both. Going to be easier. It's going to be 0.25. Okay. So what is the probability of having one or the other? Okay. So if you remember, the probability of having one or the other is going to be very simple. And sorry. So one of the things is that we have this particular right here of this of both. That means it has a little bit of A and it has a little bit of B in it. So this 0.5 is also this 0.25. Okay. We don't, when it talks about it having one or the other, we need to be very careful because we do not want this particular in this particular exercise to be double counting. So we need to be very, very careful when we're doing. And if we remember, this is called the additive law. Okay, why is this the additive? Because we can't add these together because there is a space between this whole, and I will explain it in a little bit. I'll show you a diagram where the whole of A, or the whole probability of A, can overlap with the probability of B and will be double adding. So in that situation, if you recall, we do have the particular law of the union. So what is this? If you recall, it is going to be that the probability of A plus the probability of B minus the probability of both. That will give us specifically what we need, okay? Or the or part. So let's go ahead and do it. The probability of A plus the probability of B minus the probability of both, which is going to eliminate the duplicity, is 0.65. There's another way to do it if it's easier for you guys to be able to understand that. It is subtracting that probability of both, that intersect, which would be the probability of A minus the intersect, the probability of B minus the intersect, and the probability of the intersect. And that summed up, if I sum that up, I'm going to go ahead and, if I want to sum that up, I'm going to sum this. It's going to be the exact same as this additive law. So use the one that is easier for you. Just make sure that you are not double adding. And the next one, this was, let's put A, this is B. The next one was, what is the probability of selecting an individual that does not have a credit card? So if you don't have a credit card and this contains both, okay, this is the or part. So it's either A or B or A and B, okay? So in that case, if you remember, it's always equal. The sum of the whole thing is 1. So it'd be 1 minus this or, which would be 0.35, okay? And then it says, describe based on both A and B, the event of selecting a student with a Visa card, but not a MasterCard. So a student who only has a Visa card, he does not have a MasterCard. So he is not here and definitely not here because it's not an or both. So you could by default say, oh, it's 0.5, but remember that this 0.5 still has this part of the intersect. So since we don't want the intersect, it's going to be actually this 0.25, but let's put it down here. It's this 0.5 minus the intersect, and it would be a 0.25. Okay, so we'll go here. This is where I was talking about. The whole probability, this is 0.5, this is 0.5, okay? If you sum 0.25 plus 0.25, it'll give you this right here, this 0.5, okay? So this plus this will give us this 0.5. And 0.25 plus 0.15 is going to give us this 0.4. Okay? And these intersect. This is the intersect, this right here. This intersect, the and is this 0.25. And 1 minus the sum of this, which is 0.65, if we sum it up, very bad with this, is going to give us this 0.35, okay? So if it's easier sometimes to draw it, go ahead and draw it, okay? So here it is, 0.65, 0.35, and 0.25, okay? This is the additive law, the one we said for this particular answer, okay? The next question, 40% of the houses built in an area of Quail Creek have a security system. We select 3 houses randomly, okay? Out of all the houses that we have, we're going to select 3 random, because we already know that 40% of the houses. What is the probability that 3 of the houses are going to have a security system? What is the probability that none are going to have of those 3 selected are going to have, and what is the probability of at least one of them having it? Okay, so these are independent events. That means that one does not depend on the other, and when one does not depend on another, it is very important. Why is it important? Because when they do not depend on one or the other, what is going to happen is that they're independent events, so we can use the multiplicative law, okay, because they're independent events. So we'll go down here, put question 3. Okay, the probability is 40 of having a security system. Okay, so 0.40 is that we're going to have a security system. That means that the probability of all 3 having a security system is going to be, let's put probability of A of all of them having. In this case, it's going to be 3 times multiplicative law because we're multiplying it by individual events. So it is 0.4 times 0.4 times 0.4. So the probability of all 3 houses, because this is all 3 of them having, we're multiplying it, is going to be 0.064. The probability of them not having, okay, the probability of them not having a security system is going to be the probability of B. And if you want to look at it like this, it would be the probability of not having times the probability. I'll go back and change that in a minute. The probability of not having the first house and the probability of them not having in the second house and the probability of them not having in the third house. Okay, that's what we're trying to see. And it's basically the same thing here, except here it wasn't not having, but let's say having the security system and having the security system and having the security system. That's why we have this number of, and please don't multiply this by 3. This is, don't say it is 0.4 times 3. You won't get the right answer. It's the probability of having the security system plus the probability of having the security system plus the probability of having the system. And in this case, this is the probability of none of them having it. Okay, so none of them having the security system. If we know that 0.4 is having it, that means 0.6, 0.6 times 0.6 times 0.6. That would give us the probability 0.22. Would give us a probability of none of them having it, okay? And then it says, what is the probability that at least one of the houses has a security system? Okay, so if we want this probability, well, we're going to label it probability of C. This is at least 1. So knowing that we have at least one of these houses, let's eliminate the probability of none of them having it. So it'd be 1 minus this probability of none having it. So we're playing here that the possibility of at least one having these houses, because we've eliminated the no possibility of none having it, is going to be 0.784. Okay. So there it is, if you want to look at it, because it's of them at least having one house. Here is the one of none of them having and all of them having. Okay, remember these are independent events. Now here's another one. Question 4. There's a managerial practice program for the employees of Claremont Enterprise. 80% of them are women, 20% are men. 90% of the women went to college, and 78% of the men went to college. That means the other percent didn't go. So the first thing it says, build a contingency table that shows the marginal and joint possibilities. So this is what we're going to do. Question 4. Okay, so question 4, here we have, we're going to have here, let's go ahead and put women, men, and we know that college and no college. Okay, so women, the total number of women was 0.8 of 80%, and so we know that the rest is 0.20 of the men. We also know that 90% of the women went to college, so 90%, 0.9 times this 0.8 is going to give us 0.72 went to college, and the rest of them didn't, so which 90% of 100, if we take 100 away, it's going to be 10% didn't go to college. Of this is going to be 0.08. And the same thing, if I'm not mistaken, was 0.78 that went to college of the men, of this 20%. And so it's going to be 0.22 that did go to college, that didn't go to college, I'm sorry, it's going to be 0.080. Okay, so if you want to color this, just so that we have it nice. And this is also total. Let's put total. Nice. Total. This is total. Okay, here we go. Here we go. And this we're going to add up. And we'll add these up. Okay. So that was the first thing that was asked. And it says randomly choose an employee within this group. What is the probability of that person being a woman who didn't go to college? So being a woman who did not go to college, well, this is the person you're looking for. This 0.08. That is the possibility of this person being a woman and not going to college. Okay. Randomly choose an employee within a group. That we've already done this. Determine the possibility of choosing an employee, a random employee, who went to college, given that she is a woman. So this, when we use that type of vocabulary, we know now that this is going to be a conditional probability. What is my first probability? Well, my first probability, or my probability of A, is that you're a woman. So this is going to be, let's label it A, okay, who didn't go to college, okay? I'm sorry, I'm gonna go back because I'm reading the wrong. We've already done that one. Clear all germs. Sorry. Determine the probability of choosing an employee who went to college. Here it is. A is you went to college. Given that she is a woman, this is B. Okay, so what we're doing is this, the probability, okay, of A, of her going to college, given B. That is what we want to know. And if you remember, here, this is the probability of, A intersect B, that means an and, okay, divided by the probability of B, of being a woman. That is what we're going to try to find, okay? And we'll go ahead and clear this. We'll take this out, and now we can go, okay? So again, the probability, and this is what we're looking for, is the probability of A given B is what we're going to be looking for. So the probability of A intersect B, what would be that? Remember, here it is, that you attended college, so it's in this area, okay? So you attended college and you're a woman. So this is that intersect, okay? Given the probability of me being a woman, so the probability of me being a woman is this 0.8. And that means that the probability of me attending college and being a woman is 0.90. And we already knew that because in the graph it said that, or in the story it said that, okay? Now the next thing, it says, are gender and college education independent, and why? Okay, so are gender and education independent? So the possibility of me going to college is going to be this 0.87. And it gave me the copyright. Okay. And the possibility, now, are they dependent with being a woman? So the possibility of going to college and being a woman. So the possibility of going to college, given that I'm a woman, is this one. Okay. Are they equal? Are they the same? Well, some would argue that if you take away the decimals, you could get 0.9 for both. But no, they're different. They're not the same. They're slightly different. So they're dependent. They're not independent. They're dependent events. Okay? Because they're not the same. The next question. Oh, here are the answers. Okay, here's the work if you want it. Then you have another one. Here's question 5, and we're going to leave. We'll stop it in the video here, and then we'll continue in another video for the next 5 questions. So a student takes 2 courses, a history and a math class. The probability of passing the history class is 0.6, okay? 0.6. The probability of you passing the math class is going to be 0.7. So the probability of passing both courses is 0.5. It says, what is the probability of passing at least one of the courses? Okay, and this is an or question. You either pass one or you pass the other. So in this case, if you remember, this is a great example of one of the laws. And this is the additive law. And we use the additive law because we don't want them to overlap. Okay, we don't need them to overlap. So here we go. And this is question 5. Okay, so question 5, the probability of history, we're gonna put it there. We're already getting, we don't want the same format. The probability of math, and here is the probability of both, and we'll put both. Okay, that's the intersect. So the probability of you passing math is 0.6. The probability of you, the history is 0.6. Of you passing math is 0.7. Of you passing both is 0.5. If you remember the additive law, and the additive law is, which would be the probability of H union or the union or it both goes both ways, or M, that is equal to the probability of H plus the probability of M minus the probability of both. That's the formula. So here we go. The probability of H plus the probability of M minus the probability of both will give us a 0.8. So that you'll pass one or the other, you have an 80%. Another way to do it, like we had said, it's the probability of history minus of both, the probability of math minus the intersect or what both have. If we add that up, if we add 0.1 plus 0.2 plus 0.5, it is going to give us the same answer. It depends on how you look at it. The thing is, you have to eliminate and make sure that you are not summing more probability because of the overlap, okay? So if you want to look at it, there it is. And we did that. So 0.1, 0.2, here's 0.1 of history, 0.2 of math, 0.5 of both courses. And the probability of you not passing would be actually the probability of you not passing any of them, which is this 0.2, would be 1, the whole thing, minus the or. Okay, would give you this 0.2. So these are the first 5 questions. I hope they helped you. I hope they help you review.